Okay, so that's 30 Newton. And then you see the value there, 20 Newton. However, yes, whenever you're talking about vectors, you also want to get the angle of inclination to the horizontal so that you can tell us, okay, what is the magnitude and then in what direction is it pointing to? What is the direction as well? Are we together?
Yes, sir.
Yes, sir.
Yes, so that is why we have this angle theta pointing downward here. So if you want to get this angle theta, of course, this side that is facing, this is the angle, right? So the side that the angle is facing, that is the opposite side. So that is opposite, which is this one. So you may decide to use maybe your hypotenuse side, which is this one. Of course, you expect right angle triangle to be here. So this will be hypotenuse side, which is 30 Newton, and this will be adjacent side, which is 5 Newton. So you may want to use maybe sine theta or cos theta. Okay, so that's so and car. Or you may even decide to use tan theta. So let's see. So here we decide to use tan theta, okay? So tan theta gives us, okay, what's the opposite? That's 12. What is the adjacent? That is 5. That is 2 now. So katua. Do we know that?
Yes,
Yes.
sir.
Okay, so tan theta is equals to opposite over adjacent. That's 12 divided by 5. And then we get our answer of theta by taking arctan of 12 over 5. So we have our answer to be 67 degrees. So it implies that the resultant of those two vectors will be 13 Newton, 67 degrees. So also one thing I would like you to take note of is I need you to understand something here. Uh, this board is really giving me problem. These four cardinal points and the x and y plane. So we need to understand something here quickly. So you need to know what this place is. Magic. You need to know what this place is. What this place is. What do we call this one? What do we call this one? What do we call this? 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 So this one is closing up towards this side, okay? This one is closing down towards this side, okay? This is closing up towards this side. This is closing back towards this side. This is closing back towards this. This is closing up towards this. This is closing up towards this. And then this is closing down towards this. Are we together?
Yes,
Yes,
sir.
sir.
So for this one that is going up here, this is of course this is your north. This is north. I need a thick cow pen. Why is it not thick? So this is north. This is east. This is west. And this one is the south. Okay. So if this is east, this one is going east to north. This arrow is going east to north. So this will be east. Sorry, that will be east of north. So let me say theta degree east of north, or you can call it north theta degree east. So if this is going from north to east, we call this one theta degree north of east, or east theta degree north. So for this one is going from south to east. So this will be theta degrees south of east, or east, theta degree south. This is going from east to south. So this one will be uh, from east to south. So that will be theta degree east of south, or south theta degree east. Imagine taking so much time to load up. And then for this one, this is coming from west to south. So that's west of south. So that will be theta degrees west of south, or south theta degrees west. And this is going from south to west. So that will be south of west. So theta degree south of west, or west theta degree south. Okay, the oil is causing a problem there. So I said or. Mhm. And for this one, that's west north to west. That will be theta degree north of west, or west theta degree north. And for this one, theta degree west of north, or north theta degree west. Do we understand this thing?
Yes, sir.
Okay. So someone should take a screenshot and send to the platform. When you are done taking a screenshot, let me know.
I've done it, sir.
Oh, very good. So now let's get back to that question. So I want us to report that angle in terms of this thing that I just did now. So let me get back to this. Okay. So if we got the what's it called now? If we got the angle to be 67 degrees, look at where it is pointing to. It is down here. Which is pointing in what direction? If this side is 67 degrees, this is an angle of inclination between east and south. So let's compare to what we have here. So that means the angle is here. That 67 degrees is here. Do you all agree with me? Do
Yes, sir.
you all agree?
Yes, sir.
Yes,
Okay.
sir.
Okay. So it's that the angle is here. So that means that we can report it as theta degree east of south, or south theta degree east. So in that regard, I will say that okay, the value of the resultant, we got there is 30 Newton, uh 67 degrees east of south, or I said 30 Newton south 67 degree east. Does that make sense to you? Does it make sense? Hello, can you hear me? Did you all see this resultant value when I wrote it down? Does it make sense to you? 13 Newton 67 degrees east of south, or 13 Newton south 67 degree east. Does it make sense? Can we still hear me?
Yes, sir.
I said, does it make sense? You When you look at that diagram, the angle of inclination is exactly same thing as this one. When you look at that diagram, look at the diagram here. Can you see where the angle is? So what you just do is that you just take that angle out. So this is the notation already that I've written out for you for easy recall. You just put the value there, 67 degrees east of south or south 67 degree east. Do you get that?
Yes, sir.
Okay, so let's get back to presentation then. Okay, so we're done with that. So imagine you have three vectors whereby you want to solve for the resultants of these three vectors. You can see 5 Newton inclined at an angle 90 degrees to the horizontal. You have 10 Newton at an angle of 135 degrees from the horizontal, and then you have 5 Newton along the horizontal positive x axis. So what you want to do here is that you want to of course you want to find the resultants of the well, yeah, this is another way. However, there is a way that I think will be uh okay, yeah, let me say there are two methods of solving this question. So one thing is that when you look at this question now, although this particular application that is being used here might not work for any three, like might not work for every three vectors that you might be seeing. Okay, are we getting what I'm trying to say?
Yes, sir.
So if you want to solve questions relating to three vectors like this, so first thing is that you want to resolve the vectors into x axis and y axis. So very quickly, let's do that first. Okay, this is 5, 10, 5. Okay, let's get back to the whiteboard. I think I will have to load another whiteboard now. I don't know, your network is breaking. I've been using mine. Okay,
Last physics class. Can you hear me?
what did you say? You said you joined the last physics class?
Physics class for the first physics class.
Okay, for the first physics class. Okay, so you've been joining other sessions.
First started
Okay, okay, don't worry,
I right
don't worry. Can everybody hear me clearly?
Yes,
Yes,
sir.
sir.
Okay, okay. So I think we should have a very better uh, something here. Let me look at that diagram again. Okay, 10, 5, 5 goes up there. That is looking too big. Hey, hey, I need to refresh it. In fact, you all can see that online lecturing is not easy per se. Is it easy?
No, sir.
Writing on the whiteboard is very difficult. So not everybody can actually teach online. Okay, let me see again. So 10, 5, 5. All right. So we have 5 here, Newton, 5 Newton, and then we have 10 Newton here. So the angle here is 135 degrees. And this angle 90. Okay. So Uh, in resolution of a vector, when we talk about resolution of vectors, it simply implies that you want to put vectors into y-axis components and x-axis components. You want to put it into vertical and horizontal components. So whenever you are resolving, one of your important considerations or one of the important considerations that you need to make is that you want to consider the angle of inclination to the horizontal. So now before going forward, let's say let's say you want to resolve vector vector A into x and y components. So I think I'm already used to that other whiteboard. This one is somehow for me. So let's say you want to resolve vector A into x and y components. So let's just assume that the angle of inclination is to the horizontal. So we say that A of x will be equals to A cos theta, okay? And then A of y will be equals to A sin theta. That is basically what resolution of vectors is talking about. So when you take A, let's say you take vector A for example. If you want to resolve that vector A into horizontal component, that's x, it will be A cos theta. And if you want to resolve in the y-axis direction, that will be A sin theta. And please also note that you need to take note of the direction of that. Y-axis has two places or two. Yeah, let me say two places. One above the x line and one below the x line. The one above the x line is the positive one, and the one below is the x one. So which means you have plus y here, you have negative y. And also for x axis, you have plus x and you have the negative x. So you need to know which of those areas the vector that you want to resolve falls into. Do we get that?
Yes,
Yes,
sir.
sir.
Do we get the explanation I just made now?
Yes, sir.
Yes, sir.
Oh, I've muted myself. Hello, can we hear me now?
Yes,
Yes, sir.
yes,
Okay.
sir.
So let's say I want to resolve these forces now. What if I were you in the y case? I'll first do okay f of y, f of x, f of y. So I want to resolve them. This is f of x. So if you want to resolve them, I draw a straight line. I divide, and these are the forces that I want to resolve. The forces that I want to resolve. I have 5 Newton. I have another 5 Newton, and then I have 10 Newton. Now, for the first 5 Newton, which is this one, remember I mentioned that all you have to consider for the angle that you want to take is angle of inclination to the horizontal. So this force now, the angle of inclination to the horizontal is what? 90 degrees. 90 degrees, okay? So if I want to resolve it into f of x, this direction now, you don't know whether it falls in positive x axis or negative x axis. Or you may even do it this way. You may decide to make short dashes line to trace GE. What is this one doing like this? How do I reverse that? Okay. You may even decide to divide it. I didn't say I want to put direction now. Oh, who is sending this one message? Aha. So it goes like this. I don't know if what I'm doing makes sense to you. What I'm trying to do is that you want to know which what's it called now? You want to break it into components using the coordinates x and y. So this first 5 Newton falls in the positive y. This positive y, positive x, negative y, and negative x. Okay. So the 5 Newton now it falls in positive y, and for the x you don't really know because it's in between. However, you don't need to be concerned because at the end of the day your answer will be zero, which we are going to see shortly. So for the angle of inclination to the horizontal, remember I mentioned that for any of the forces that you want to resolve, whether to the x-axis or to the y-axis, this angle theta that you want to consider must be the angle of inclination to the horizontal, which we use for both of them. So now angle for this 5 Newton, angle of inclination to the horizontal is 90 degrees. So what I'm going to do for f of x, because I don't know whether it's a positive or negative, I can say plus or minus 5 cos 90. And for f of y, that falls in what? In the positive y-axis. So I will say this one is plus 5 sin 90. Do we get that?
Yes, sir.
Yes, sir.
However, you don't really need this.
Sir, please, why is f of x plus or minus
Thank
5
you.
cos 90?
The reason we use plus or minus 5 is because on the if 5 Newton is on this line of this y-axis, that means it is in between plus x. Sorry, that means it is in between plus x and negative x. However, what I wanted to say is that you don't need to be so much concerned about maybe plus or negative because whatever the value there will still give you zero because cos 90 at the end of the day will still give you zero. So this plus or minus here doesn't really need to give any concern because cos 90 of that value will still give you what? Zero. Do you understand now?
Yes, sir.
Yes.
Yes, sir.
So I didn't just want to put positive there and I didn't just want to put negative there. So I want you to know the exact thing there. Now for the next 5, which yes, you understand this one as well. Look at this next 5. This one is directly on the x-axis, on the positive x-axis. So what is the angle of inclination to the horizontal? The angle of inclination to the horizontal is basically zero. Why? Because it lies on that same horizontal axis. Does it make sense?
Yes, sir.
For this one has angle of inclination to the horizontal, which is this angle here. This is your horizontal. These are your horizontal. This from here to here is the horizontal line. That's the horizontal line. So this one that goes up, it has angle of inclination to the horizontal, which is angle 90 degrees. However, this 5 Newton that points in this direction, sorry, I'm supposed to put direction there because there's a vector there. The 5 Newton that points towards that direction is lying directly on that x-axis. So there's no angle of inclination there whatsoever. So the angle there is zero. So if angle of inclination for this one is zero, I will now say for the x-axis now, that's in a positive, right? I'll say plus 5 cos 0. And for the y-axis, because I'm not sure as well, I don't know whether because it falls in between, I don't know whether it falls in the positive or negative. So I'll just say plus 5 sin 0. This one, so you don't need to be so much concerned about the positive or negative. Reason why? Because sin 0 is still 0. So at the end of the day, it will be 0. So that will tell you that whether you have positive or minus, the plus or minus will later cancel out there. Now for this 10 Newton, look at this one here. They told you that okay, from here to here is 135. You should definitely know that from here to here is 90, right? If from this place to this place is 90, then the remaining will be what? What will be this remaining one? This remaining small will be what?
130 minus 90.
135 minus 90 is what?
45.
So this small angle is 45. So if that side is 45 degree, you can now see that this 45 degree is angle of inclination to the vertical. Remember I mentioned that what you need, the angle you need is angle of inclination to the horizontal. So if this is to the vertical, then I need to compute the one to the horizontal. Of course, should also be what? 45 degrees. Does it make sense?
Yes, sir.
Meaning,
Yes, sir.
meaning that if you are having angle inclined to the vertical, you must find the one inclined to the horizontal. Not that you can't work with the one inclined to the vertical, but then this your resolution trigonometric ratios or trigonometric identities would change. A of x then become a sin theta and then a of y becomes a cos theta. So I don't want that one to confuse you rather. So always work with angle of inclination to the horizontal. It makes it easier. So now angle of inclination to the horizontal that I'm working with here is 45 degree and the force is 10 Newton. So now for the x axis, this point in negative x axis, it falls the negative x axis as you can see. So to resolve, I will say that this will be minus 10 cos 45. It also falls in negative y-axis as you can see. It falls in negative y-axis as when something points downward here is both negative x and negative y. So this will be minus 10 sine 45. Okay, so that is all. So you want to compute them together. So the value you get here, that we call it summation f of x is equals to what? The value you get here, that summation f of y is equals to what? So this one, this value, that value there is 0, right? This one, 5. This one, minus 10 cos 45 is what?
Minus 5 root 2.
Minus 5 root 2. And that is what? Minus 7.07, abi?
Yes, sir.
Okay. Now, this one, 5 sin 90. Sin 90 is 1. That's 5 Newton. Sin 0 is 0. And this one, minus 10 sin 45. Minus 7.07, abi?
Yes, sir.
So someone should add this one and this one together. That will be minus 2.07, abi? Someone should confirm that for me.
Yes, sir.
Yes, sir.
And this one as well, minus 2.07, right?
Yes, sir.
So it implies that you have minus 2.07 for solution f of x, minus 2.07 for solution f of y. Now, when you want to get a resultant value, your resultant will be equal to square root. Or before that, let's before that, what you just did is that you just resolved them into x and y. So what you're now going to do is that you're now going to draw another cardinal point showing the direction. Sorry, wait, that line is not straight. Okay, look at this guy. For x, minus 2.07 should be somewhere here. Abi, is on the x axis. That's where you have minus 2.07. For the y, minus 2.07. So that should also be down here, right? That's where you have minus 2.07. So you have this one. This one goes this way. That's where you have the arrow. And then you have this one goes that way. That's where you have the arrow. Okay. So they are joined together tail to tail. So you are going to use your parallelogram law of vector addition. However, because at this junction here, the angle of inclination there is 90 degrees. Your parallelogram law of vector sum up to r square is equal to a square plus b square plus 2ab, sorry, plus 2ab cos theta, right? So remember, if theta, which is the angle between them, is 90 degree, the equation change is reduced to a squared plus b squared. Are we together? Are we
Yes, sir.
okay? So then r squared is equals to minus 2.07 squared plus minus 2.07 squared. What do we have? R squared is equals to this plus this. What's the answer? 2.07 squared plus 2.07 squared.
8.56.
6.56. So take the square root of the answer. R is equals to square root of,
8.57.
okay, 8.57. Okay,
8.57. Yes, sir.
8.57. So take the square root of 8.57. What do we have?
2.93.
2.93 Newton. Okay, so that will be your resultant. Now, if you want to get the angle, remember I mentioned that when you have vectors like this, you can always get the angle of your resultant. The resultant, since it's a parallelogram law, the resultant is a line drawn from the point of intersection downward, right? And that makes a certain angle to the horizontal, okay, which is angle theta. So if you want to get angle theta now, let me say I want to use tan. Tan theta is equals to opposite over adjacent. Opposite over adjacent. So tan theta is equals to minus 2.07 divided by minus 2.07. So you have tan theta is equals to 1. Theta is equals to arctan of 1, right? Which is equals to what? 45 degrees. Is that not so?
Yes, sir.
Okay. I hope we understand this resolution of vectors into components. Does it make sense to you? I hope it does make sense. So now
Yes,
let's
sir.
get back to our presentation. So in our presentation, we used another method, but I earlier mentioned that this method used in the presentation does not necessarily work for everything because it might not be directly straight like this. It might come like this. It might go somehow. So, but because this one is straight, is the reason why it's able to align together. Let me let me show the presentation so that you can understand what I'm trying to say. So because we can draw I've seen a jump question like this before. This aligns up like this and then this tallies like this. So the resultant of these two, this 5 and 5, can be drawn from this point of intersection upward, which you see there. Can you see that? So when you find the value of that resultant there using the parallelogram law of vector, you get 7.07 Newton here. Okay. Now you get the angle to be 45 degrees. Okay. Now you want to find the resultant of 10 and 7.07 Newton forces. So and the two forces are in straight line. They are in straight line and they are in opposite directions. This one points downward and that one points upward. And then where we do that, so resultant is 2.93 Newton. Was that what we got as well? What did we get here? Okay, can you see that? Do you appreciate that solution? Am I still connected?
Yes, sir.
Yes, sir.
Do you understand what was presented in the presentation?
Yes,
I'm
sir.
not sure if you understood that. This is the diagram of the question. So first thing is that we first took the resultants of these two ones here because we could easily use parallelogram laws of vectors. And when you now draw the parallelogram law of vectors, it happens to be that that straight line merges together with this straight line 10 Newton force that is pointing downward. And the angle here 45 degree when you sum up with this 135, it happens to be that it is angle on a straight line that sum up to be 180 degrees. So we first look for the resultant here, we got 7.07 Newton, and then when we do that, we find the resultants of the 10 Newton and the 7.07 Newton on the straight line, and the two forces are in a straight line because of the summation of this 45 and 135, which is 180 degrees. However, they point in opposite directions. This point upward and this point downward rather, and this one points upward. So 10 Newton, 7.07 Newton, and then we subtract. So the resultant value, because they are pointing in opposite direction, we do 10 minus 7.07, we have 2.93 Newton in the direction of the 10 Newton force that is pointing downward. Okay. So recap. What is a scalar quantity? Give two examples. What is a vector quantity? Give two examples. How are vectors represented? What is the resultant of two vector quantities? What is triangular law or triangle law? What is the parallelogram law? And then resolving a vector. Snap this, send to the group as an assignment. Okay. Popola, please help me to do that.
I've done that, sir.
Send to the platform for assignment. Okay. So resolving a vector into perpendicular components, you have it straight down here. When resolving a vector into components, we are doing the opposite to find the resultant. Yes, I've done that one already. I've explained the solution of vectors into components. Uh, yes, I had already explained that this is resolution to the this is the vector v. So you want to resolve to the vertical, that's for this one. And also you want to resolve to the horizontal, that's this one. I had already explained that. So to resolve to this one, remember you're going to use the angle of inclination to the horizontal, which is this one here. So you have this one to be v sin theta, and you're going to have this one to be v cos theta. So these are practical applications. So here we see a table being pulled by a force of 50 Newton at a 30-degree angle to the horizontal. So when we solve, we see that this is the same as pulling the table up with a force of 25 Newton and pulling it horizontally with a force of 43.3 Newton. Yes, what is there basically, what we did there is just that we resolve it into vertical. That is 50 sine 30, and sine 30 is half. So that's 50 divided by 2, that's 25 Newton. And then you solve into horizontal as well. That's 50 cos 30, that's 43.3 Newton. Does that make sense?
Yes, sir.
Very good. I hope everybody understands what I'm trying to say. This is just resolution of vectors into horizontal and vertical components. It makes sense, right? This is the force.
Yes, sir.
This is the vector 50 Newton. You want to resolve it to vertical and horizontal. So vertical, that will be 50 sine 30, horizontal 50 cos 30. And we can see that it will be more efficient to pull the table with the horizontal force of 50 Newton. So calculating the magnitude of perpendicular components, so that is that v cos theta and y is equal to v sin theta. Can we see that? And a proof is just some kind of mathematical proofs there, which is not necessary. So this is a question. So this is a problem. So you have a force 50 Newton that is inclined at an angle of 60 degrees to the horizontal. So what do you want to do? You want to resolve them and say, can you see what the question says? What is the horizontal component of the force? So to get the horizontal components of the force imply you want to resolve to this line, and that will be what? Who can tell me? If you want to resolve it to this horizontal axis, what would it be?
Yes.
You say what?
Cos 60.
15 cos 60.
15 cos 60.
That's good. So that will be 15 cos 60, okay? So horizontal vertical, so horizontal 15 cos 60, that's 7.5 Newton. And then to your vertical, you have 12.99 Newton, okay? So you see, a person in a wheelchair is moving up a ramp at a constant speed, and their total weight is 900 Newton. The ramp makes an angle of 10 degrees with the horizontal. Calculate the force required to keep the wheelchair moving at constant speed up the ramp. So if you want to do that, it is basically asking you to get the what's it called now? Uh, okay. Anyways, I think this is what's it called now? The question says calculate the force required to keep the wheelchair moving at constant speed up, moving at constant speed. Where is it? Okay, up the ramp, abi. So if the wheelchair is moving at constant speed, no acceleration, then the force that moves it up the ramp must be same as the component of its weight parallel to the ramp. So the one that is parallel to the ramp, this is it here. Oh, to move up, right? Yeah, is to be pulled up in this direction. So that must be same as the weight component of that man that is going down the plane. So this is going down the plane. So you need to calculate the one going up the plane, and that will be same as this weight component. So that will just be you solve, and it tends to be mg sine theta. So mg, that is the weight. The weight is 900 newton. So we'll do more of this when we get to friction forces and all of that. So in summary, I'm already tired. So you have this summary, everything has already been explained. So into x and y components, and that will be all for the presentation. Okay. Any question or questions? Any question or questions? Anybody?
No.
Yes, Mr. Can I listen to your question?
The first example you gave. No, the second example.
Which
There is a place around. You got
which
something. I don't get that side, but
which second example? Can you be specific? There are a lot of examples we discussed about here. Which one? Which one?
my notes.
You said what? I can't hear what she's saying. Can anybody hear her? Hello, ba? Oh, mi ì rí bí sọ yìí. Màá pè é padà, mò ń ṣe kíláàsì lọ́wọ́ báyìí, ṣẹ́gbọ́. Màá pè é.